Every team drowns in meeting recordings nobody rewatches. Today we dissect one realistic reference architecture that ingests an audio file, transcribes it with speaker labels, and produces a structured summary with action items. By the end, you'll understand each component, how requests and data flow through it, the 3 failure modes that bite you in production, and the trade-offs an architect weighs between cost, latency, and accuracy. This isn't a Hello World demo. We're building something you could actually ship behind an internal portal, and I'll flag where you should double-check current Azure docs because pricing and model names change often. Here's the wiring. A user uploads a recording through a PI management, which fronts an Azure function. The function drops the file into Blob Storage and kicks off Azure AI Speech batch transcription, which reads directly from that blob. When transcription completes, the function pulls the result, chunks it, and calls Azure OpenAI to generate the summary. The final document lands back in Blob Storage and metadata goes to Cosmos DB for querying. Notice the dashed arrows. Transcription and OpenAI calls are asynchronous and can take minutes, so nothing in this path blocks an HTTP request waiting on them. Walk the happy path. The function generates a short-lived shared access signature for the uploaded blob and submits a batch transcription job to the speech service, pointing it at that SAS-URL. Batch transcription runs server-side and supports diarization, so the output tags who spoke when. The function doesn't poll in a tight loop. It stores the job ID and lets a timer-triggered function or an event grid notification check completion. When the job finishes, you fetch a JSON transcript with timestamps, confidence scores, and speaker labels, then write the clean text back to Blob Storage as the input for summarization. Why batch and not real-time? This is a deliberate trade-off. Real-time streaming transcription gives you sub-second latency and live captions, but you pay for a held open connection and you own the retry logic if the stream drops. Batch transcription processes a whole file asynchronously, scales to long recordings, and is cheaper per audio hour for offline work. For a meeting summarizer where the recording already exists, batch wins on cost and operational simplicity. If you needed live in-meeting notes, you'd flip to the real-time SDK. Pick based on whether the audio is bounded and already complete. A 2-hour meeting transcript easily blows past a model's context window, so you chunk. Split the transcript on speaker turns or token count, summarize each chunk, then run a final reduce pass that merges the partial summaries into decisions and action items. This MapReduce pattern keeps each call within limits and improves quality. Here's the core call. Notice we set a low temperature for consistency and ask for structured output so downstream parsing is reliable. Keep your endpoint and key in Key Vault, never in code, and check current docs for the exact model and a PI version since these deprecate. 3 failure modes to design for. First, the transcription job fails or returns low confidence garbage on noisy audio. Store confidence scores and flag transcripts below a threshold for human review. Second, the OpenAI call hits a rate limit or token cap during a traffic spike. Implement exponential backoff and consider provisioned throughput units if you need predictable capacity. Third, orphaned state. The function crashes between submitting a job and recording its ID, leaving a job nobody tracks. Make the orchestration idempotent and persist the job ID before the long-running call returns, so a retry can resume instead of duplicating work. Step back to the decisions an architect actually made. Serverless functions over a hosted container, bursty, infrequent workload, so paper execution beats an idle cluster. Blob Storage as the shared data plane. Both speech and OpenAI read from it, decoupling the stages. Cosmos DB for metadata because queries are simple key lookups and you want low latency reads. And API management out front for auth, rate limiting, and a stable contract. None of these are free. API management has a meaningful monthly floor on dedicated tiers. The consumption tier may suit a low-volume internal tool, so size it to real traffic. To recap, upload to Blob, batch transcribe with Azure AI Speech and diarization, chunk and map reduce through Azure OpenAI, and persist results with metadata in Cosmos DB, all orchestrated by functions behind API management. The async, decoupled design is what makes it resilient to long jobs and rate limits. Your concrete next step: build the transcription stage alone first. Confirm you get clean diarized text on a real recording. Then layer summarization on top. Don't wire everything at once. And before you commit to model choices or pricing, check the current Azure docs, because SDK versions and rates shift constantly. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.